Okay, hello to my short tutorial. I will show you really quick, I hope, how to set up testing in Unity to perform something called test-driven development for VRChat worlds that are based on Udon. For that I'm going to create a new Unity 2019 project. It's just going to be a regular 3D project, and I'm going to create this really quick. And after a couple of seconds this should be loaded. This will be a default project, there's nothing added yet. I will quickly after that import the required packages. That would be one, the Unity VRChat SDK for SDK3 worlds, UdonSharp, and optionally CynEmu. So here's the new project. I'm gonna switch to the default layout really quick so it doesn't confuse anyone. Here we have the default layout, and we need a couple of packages, as I mentioned. As the first one, the latest VRChat SDK. In this case, it's the Unity 2019 Beta SDK. I'm going to use Unity 2019 just because it's going to be the standard soon. You see, and here it's loading. So that is the SDK. I'm just going to import it. Will take a couple of seconds. And here we go. Okay, the SDK is loaded. Next is Udonsharp. So I'm just gonna drag it into my editor again. And I'm gonna wait really quick until everything is done. Finally it came back, so UdonSharp, import. And that is that. So I've had the SDK, I'm gonna log in really quick. And now we're good to go. So the first thing you want to do, if you want to do test-driven development, you want to probably create a directory where you put all your stuff in. So I'm just gonna call mine Goribo, as there will be my stuff inside. So as it's Goribo. And Unity comes with a really nice thing where it actually creates stuff for you. So when you go to create, so content browser project, right click, create, testing, tests, assembly folder. You just click that, and in my case I just call it tests, yes. Click enter, and once you go inside you will find an assembly definition file. This is the default it creates usually. So the first thing I'm already going to change is the name of the file. So it's in Goribo tests right now, so I'm going to call it goribo.tests. What assembly definition files are basically, they define what parts of your code get compiled to one dynamic linked library. But as we're doing this for VRChat, we don't really need dynamic linked libraries. It's just required for testing overall. So as you can see, this was already created with testing in mind. So it added the test runner for both editor tests and playmode tests, and it added the framework that allows using assertions in the test mode. So this one doesn't restrict the building to any platform, so this will be usable in editor and on like regular Windows platforms. So what I like to do usually is I like to do editor tests primarily. I create another directory, call it editor, and I will go in here. I create a duplicate of this one. Oh, that was the folder, sorry. I will duplicate this one. This one will be, I forgot one thing, Goribo, that's the new one. Let's do the old one. Goribo, come on, Goribo.tests, and I will call this one runtime actually. So I'm not going to change this one. Click apply. So Goribo tests runtime. I'm going to rename this as well to reflect that. runtime, and I'll create a directory called runtime. So in here there could be all play mode tests, and I drag that thing in there. And the other one, the duplicate I created earlier, I'll drag into editor, wait for it to do its thing, and I go in here. So here you can see I have Goribo tests. Come on, editor. Where's the lighting setting? Light settings. I'm gonna turn recompiling off. Oh, it's actually off. Never mind. So I have editor. Here I still need to change it. I'm gonna change this so that I can see everything. Call this one .editor. Copy the name. Enter. Change the name here too. And instead of using all platforms, I'm going to choose only editor. Okay, deselect all and then editor. And here we go. Nice, that is done. So now we have the ability to test something. We don't have anything yet. But test-driven development is all about writing tests first and writing the code afterwards. So you only create so much test code until it fails. And as soon as it fails, you write quote-unquote production code until the test passes again. And then you do some refactoring if necessary. So here we have our tests folder. It's empty right now. We have no tests. So I'm going to create a test. So it gives you, in the same menu which we used earlier to create the test assembly folder, we use this option to create a test script. Now I can think already about what I want to create. So let's create something like a very basic door, where a game object is being moved out of the way so that the player can pass through. So I call it, let's say, test door or door test. And I'll enter and it creates this template for me, and now I can open the test and start coding. So I open it. Writer will open up for me in a bit. Yes, I trust this project. So here I am in Writer. By default it creates these two default tests. As this is an editor test, I don't need this one. This is for runtime testing. So I just delete this one. This one asserts nothing for now, and it will just pass. To test this, you can already see Writer shows me that these are tests and they can be run. So I'm going to change the namespace here. I'll just do the default. It moves it to Goribo tests editor. So this is fine. I'll do that. It updates this. The unused imports disappear. So that's fine. So this one does nothing for now. And to check that this works, I go back to Unity. And I give Unity a bit of time, as usual. So how do we test? In Unity there is a window called test runner. There it is. It's in general. So window, general, test runner. I open that one up. Yes, where did it go? Test runner. Oh, okay, it opened on my second monitor, never mind. So this is what it looks like. It has play mode and edit mode. You can... No, they didn't add that yet. So you can switch between play mode and edit mode. I prefer edit mode tests. So you can already see I created one test and it was called door test, and there is nothing in it except the example default test. You can ignore this one. This is, I think, from Udon Sharp. So this is the first test. I can just click run all and it should immediately pass. So it ran both tests, mine and the Udonsharp test, both passed. Mine passed obviously because it did nothing. So I'm just going to move this to the side here now. So obviously I don't always want to test in the editor. I can test directly from Udonsharp, Writer, sorry. So once I'm in Writer, you can see there's a test. I can start tests individually or all of them. So if you go to the window that you might have called tests, unit tests, you find the test as well, and then you can click this button and it will run all the tests. And if it fails, I can show you how to make a test fail really quick, and then we get to see how that looks too. So it defaulted to edit mode as I'm running edit mode tests here, and Oh yeah, I forgot to mention, when you do that, usually you have to go to Unity really quick, because always wants to make sure that you saved your scene. I don't need to save anything. Test ran, it creates this test scene, this temporary test scene, and then it's done. And Radar notifies me that it's done here too. So here's the test. It passed, nothing went wrong. So let's make it fail really quick to show how that looks. So I do assert and say I want something to be true, and I pass false. This will obviously, hopefully, that's obvious, make this test fail. I save the file, it's refreshing in Unity. So first I'm going to test it in Unity and show you how that looks. And then I'm going to do the same again in Radar. So here's the test, I changed it. I can run that directly, only this one. I don't want to save. And it failed. And you can see it expected true, but it was false. And then it tells you a bit of where that was. Then you have the option to go to the error line, and it jumps to your IDE and shows you what went wrong. The second way to do it is do it here. So I run it again. I make sure I go to Unity, it loads a bit, that nothing gets saved, and test is completed, and voila, it failed. And it gives you the same. The difference is it gives you the link directly, what failed, and you can jump to it, and voila, there's the error. So test-driven development. Obviously you have no code yet, nothing except a test. To create a test in Radar, all you have to do is type test, and it will give you a macro that creates a test for you. Let's say I want to create a door script now, an UdonSharp script that opens the door when you interact with an object. Nothing more. So I'm going to call this one open door. And obviously we have no script yet, but we can be naive and say we have it already. So I'm going to create the behavior. I call it door. And I'm going to put it on a new game object. New game object. And add the component that doesn't exist yet and call it door. So this doesn't compile, obviously, but with test-driven development you only write so much test code until it fails. Failure includes the code doesn't compile. So the next thing is make it compile. So we don't have a door yet. So how to fix it? We create a door, a script. So I go to Unity again, and in my folder Guribo, there's only tests right now. I have no runtime code. So I create a folder for everything that's supposed to go into Unity, into VRChat once, at some point. So I create a folder, call it runtime, just to be clear of what the difference is. These are just tests. This is runtime. So I go in. I have to create a assembly definition now. Otherwise the test assemblies won't know what code belongs to it. So I create an assembly definition. I call it Guribo.runtime. You can call it whatever you want. So if you create something for a door, you could call this Guribo doors or your name doors, whatever. So I just call this one for this tutorial just Guribo.runtime and nothing more. And when I go to the inspector, it has the default ones. I don't like this. So what this does, it uses not readable names but only IDs. I can show you what that looks like. So if I go into this one and look for Guribo runtime. Okay, it doesn't find it here, but it finds it here. So here's the file guribo.runtime.asmdf, and in here you see it just says guribo.runtime for now. So I'm gonna untick this. There's nothing in here yet, and click apply. Okay, it defaults to that. Okay, it will change later once we actually reference something. So now we have the assembly definition file, and now we can create our new script. And here we just go to the creation menu, UdonSharp script, and I wait for my PC to struggle. And here we are in that directory, and I'm calling this one door. So here's our door script. It's empty. It has start in it. It's the default Udon behavior. And here's the program to it. And it could not be found yet. Let's open it up here, but that arrow just indicates that the test itself here fails. So it doesn't know Udonsharp yet. Okay, we can fix that. So as we created a assembly definition file here, it doesn't know about the VRChat SDK. The VRChat SDK is here though, so we just need to reference it. So click the plus button, and here we have VRC Udon, and that is not the only one we need. Go with that one for now. We also need Udon Sharp runtime assembly, and I believe that's it. And here, so I'm going to leave this one for now and show you the difference. So I click apply. Now we have VRC Udon, Udon Sharp runtime assembly. So now the code should in theory know about this stuff. As you can see, the red goes away. It knows about it now. And in here we can see this is the assembly definition of the runtime directory. These are the GUIDs. And this is obviously not really usable. It doesn't tell you what it is when you look at it. To fix, I wouldn't say fix it, but to make it more readable, just untick this one, click apply. It will reload. And when you go here, boom, there it is. VRChat, VRC Udon, Udon Sharp runtime. Much easier to read. And in here, okay, the test itself is fine now. It compiles, there's no errors, there's a warning here regarding namespace. I can fix that really quick. I'll copy this just to make sure. And I'll do the autocomplete thing, which basically does this. It moves it to the runtime namespace. Does that, but also removes my using statements. I'll just paste the old ones back in. There's nothing. I don't need start yet, so I'll just delete it. And in the door test, okay, we don't have the door yet. What's missing is the test assembly definition file. Doesn't know yet about runtime. So I go back to my editor tests, to my assembly definition file, go to the assembly definition references, click plus, and then I reference runtime, and I click apply. And now the console, if I clear it, there is one error missing. It doesn't know about door yet, okay, but that's only now because I'm missing the using state. When I go here now, it actually knows what it is now, so it's missing that. So I'll do the auto fix, and there it is, using runtime. Here's the test. When I test it now, I can do it in the IDE. Am I missing something? Give me one moment. Oh, I found the error. So it wasn't this one. It was actually missing it on the test assembly. So I go to tests editor and the assembly definition file. And here I need to apparently add VRC Udon and runtime assembly of Udon Sharp and the editor assembly. And I hope now that is fixed. There we go. It looks like it compiles. Yep, it compiles. So to reiterate on that, the test includes the test runner for the engine and the editor, runtime, VRC.udon, UdonSharp runtime assembly, and because this is for editor test, the UdonSharp editor assembly as well. And here is only ticked for editors. So now we have our test. It contains nothing but, as I showed before, it contains the creation of a game object, and I add the component, the UdonSharpBehaviour Door, which does nothing yet, but that is fine. So in the test runner I have this test. It was failing previously, and as I mentioned before, you only write as much code, so much code as is necessary to make a failing test pass. So this test wasn't compiling, now it compiles. Now if I rerun that, wrong option, rerun that, it passes. So first step done. I have a door. This door does nothing. What do I do with the door? Once it's in your world, you usually interact with the door by interacting with it. So every Udon behavior, or in this case Udon Sharp behavior, has a function called interact. So interact does nothing, it's void. So our component doesn't have an interact yet. So I go back to my door and I create this function. I call it public void, override void actually, interact. Was it interact or an interact? Or I can just generate it. I'm not sure if it was overrideable. There it is. Public override void interact. Oh, why didn't it recognize it? So here's the interact function. It does nothing yet. So I said earlier I want a door that slides up, right? So I want something that is being moved by the door. I don't want to use an animation, I'm just going to set it in code. So I want the door to have a transform that it's moving. So my first assertion could be something like assert not null door dot, and now I'm gonna think of the name, door transform or door object I'll call it. And I want this to be not null. It doesn't exist yet. It's also something that is null by default here, so I create it. So the writer is so nice to give me this action list. I can create the field door object. It doesn't know what it's supposed to be. I call this transform. I want it to be a transform. So this will be a child of this object. I know that already, so I can come up with that idea. So in this case it's null. So what I need a second game object. So to make this pass, right now it fails. So if I run this fails. Wait for it. Recompiling. Don't save. And there we go. Test failed. It failed, expected not null, but it was null. Okay. So I need a second game object. So I write door object equals new game object dot transform. So this will now no longer fail. If I run this one, so everything I'm doing here is basically what you would do in your scene. But for testing purposes, I'm going to create everything in code here. So the first thing passes. The door is no longer null. The next thing is I want this door to be a child object of the first door object. So this is the door object that is actually being moved, and this is the door that is just sitting statically in your scene. So I'm going to check assert true in this case, or I equal actually, and parent and child relationships are usually handled with a transform on a game object. So I want the transform of the door dot transform. I want that to be the parent of door object, and there we have it. So this will fail right now, and I can demonstrate that by just running this test. So okay, wasn't done yet. Here we go. This is the only downside with testing in Unity. It is kind of slow. So it failed. Yeah, it expected empty, but it was not empty. Whoops. Oh, actually, it was null. So to fix that, I say door object parent is door transform. I'm not really testing anything useful yet. I'm going to refactor this really quick. So I'm going to call this parent. So the parent is just the door's transform, basically. So this test should pass now. And as you can see, I'm not doing a lot, but I'm continuously adding not really any functionality yet, because I'm still just setting up the script. And as you can see, I'm doing this in the test, which is not really where it belongs. I'm going to show you in the next 2 steps how to actually set it up properly. So we run this now. I make it pass first before I refactor it. So here we go, the test passes. So this is obviously not nice. I'm not really doing anything that's interact related. So I create a new function and call it public void prepare. And when you prepare, you usually want to clean up something afterwards. Public void cleanup. They don't do anything yet. This one gets the attribute test setup. What's it called? Setup? Yeah. And the other one is called teardown. So everything I created here, I only need to do once, and I can ideally reuse it in multiple tests. So at this point here, I have a valid door. Valid door. And all of that can actually be moved to prepare. So I'll just cut that out, put it here, and to use this one in here I need to make it a member variable. So I just write private door, delete this one, so I have my door reference. I'm gonna do this stuff, it does the same thing, and at the very end I'll destroy this one again. So I can insert, if necessary, a not null door just to make sure, and then there is the function called object.destroyImmediate because we're in edit mode. I'm going to use it on the door's game object. This is technically not really necessary, but Unity does it for you, but for completeness sake I'll do this here. So when we're in here now, we have now a valid door. We don't need to test it anymore. It is tested because it's running the prepare functions already, which have the assertions in them. So here the door has a child object which is attached to this object. And I could verify that the initial position is 0, so I could do this. So I'll write assert dot r equal, and I'll say I want the expected value to be vector 3.0, and I want to compare that 0 value to door.doorObject.transform dot local position. So in local space of the door itself, I want the door object that's going to move not be moved yet. I want it to be in the default location. So I would do this in front of the interact, because after the interact I expect it to be different. So if I rerun this, nothing should have changed. I refactored a bit, but the code itself, the functionality hasn't changed yet. So I can confirm this by going to Unity and running the test again. And as you can see, it immediately passed. So I can demonstrate this here too. Run, select the unit test, and once it comes down, everything is still green. So we're good. So our interact function is empty yet. So what I said earlier, I want the door to move as soon as I interact, right? So I'll just copy this one and I'll say I want it to move 2 meters up. So instead of this, I just say vector 3.up times 2. I want it 2 meters above the ground as soon as I interact. And I'll just do the same check again. And because it complains here, I can do this in the next step actually. So it doesn't complain just once. So this test fails because I haven't moved the door yet. So as soon as I run it, test failed. It expected 2, but it was 0. Okay, we have to write production code. We go into the interact function. We have the door object, and I want to set it upwards. So basically on interact, I'm going to be naive and assume this is valid for now, because in the next check we can actually make sure that this is valid, or make this script interact differently. So I'm going to do door object local position is vector 3 up, where is it, times 2. So this will make the test pass, as I hope to demonstrate. Run, and test passed. And for completeness sake, I created second test, invalid. I call this one invalid door object. So to be sure that your code is safe, always assume the worst. Let's say this does nothing yet. I'm gonna make sure that the door object is invalid. So I said door.doorObject. Actually, I'm gonna do object.destroyImmediate on the door object, so it's gone. So remember, I created in prepare, and I'm gonna destroy the parent in cleanup, and now I'm gonna destroy the door object that I'm gonna move first, so it's invalid. I'm gonna double check this with assert null on the door object. That is actually gone. This should still pass. I'm not going to continue here. But as soon as I interact here, this one should fail. So when I run this one should fail because of a null pointer exception. Yeah, so it expected null but was empty, but probably not where I wanted it, but before. Okay, So I have to actually fix this by saying afterwards, oh, I made a mistake actually. It's not door.gameObject, but door.doorObject gameObject. So I should probably rename this one, what could I call it? I just call it doorObject for now, whatever. So well, let's call it main movable door. So this is a transform, right? So it's a transform, and of that transform I get the actual game object and destroy that. And then the transform should be invalid. I'm gonna retest this to make sure that this works. So this one will be a bit longer, I guess. Did it run? Oh yeah, actually, oh, it has a different one. And it's here. So the easiest way is probably to just set this one null afterwards, because this one checks differently apparently. Okay, now it should work for real. As you can see, you always have to do only one little thing, retest, and you iteratively work towards the goal of having everything tested. So it fails here now where I expected. So the door is not set. Oh, it doesn't like that apparently. Maybe my English is bad. So movable door, local position, this fails because this one is null, as I said it null before, and it can't access local position of nothing, so it fails. To fix that, so this one should obviously not fail like that. I go in and we make sure that if this is null, we just leave. So if not, there's this utilities function is valid, created by the VRChat guys, that we can use to verify that something is valid. I prefer this over the regular not equal null check, because sometimes, as you saw earlier, game objects can be pending destroy, and then that might not always be caught by a regular null check, as you saw earlier. So this should work now. So when this is invalid, we leave and nothing happens. We can verify this. We actually can't verify this afterwards. You could verify this if you used error messages. So I run this again, and the test passes. And as you can see, we have two functions, interact, two test functions. One is for interact, I rename this really quick to reflect that. Interact invalid door, valid door. I'm gonna rename refactor this one, movable, called door transform. This one, I shouldn't complain about that one because this would be a different thing afterwards. So I ignore this one. Actually, does that make sense? Yeah, it probably does. So I can assert here no throw or something. Does not throw. That is kind of stupid, okay. I guess I don't have to really do it. It would be kind of weird. I could do this, so I don't expect this to throw. So the difference wouldn't be, like, the test would abort anyways. But this is probably better to show whoever reads this code to see what I'm doing here. So I run everything again, just to make sure nothing broke when I refactored it. And here we have it. So now we're at the point where we can actually like try it for once in the editor. So we have the sample scene here. Unity comes with VRChat, the VRChat SDK comes with examples. So we have scenes here. Sample scene, sample asset, Udon blank canvas, Udon example scene. Let it load. Okay, here we have the example scene. Oh wow, my edit is slow. So I create a cube somewhere there and two more cubes. So these will be the door kind of, and this one will be moving. And I need something to interact with. So I create a very basic sphere. So this will be, let's go here. Yeah. So this is what we will be interacting with. So to use the script, I add the door. There's our script, and we have this fancy little button called convert to UdonBehaviour, and here we have the behavior. So call this one open door. And it needs the thing that we're gonna move. As I said, I want to move the middle one. So I'm gonna select it, or like go to my sphere that is interactable, and I drag the door part in. So I call this one move level. And by default, I said it should be 0, right? That is probably not ideal. I'm just really realizing that now. So my test would actually fail. Yeah, let's make it a different path. Doesn't really matter. I'm just doing my test to ensure that my test is at least working. So here's the door. The object is at the exact same location, so the local position of this thing is 0 as I tested it. So as my script moves it 2 meters up, as soon as I interact with it, this will be at 2 meters. So this is the interactable thing, and now I need CynEmu. Come on. Here's CynEmu. I'll just drag it into my project. I think I'm just gonna do it this way. Assets. There we go. Okay. Because I still had the search in here. So here we have CynEmu. Thanks to Cyn, we have this very cool tool which allows playing in the Unity editor as if we were playing in the VRChat client. So once that's all loaded, we have, hopefully in a couple of seconds, the CynEmu settings here. So it is enabled by default. I just drag it somewhere, let's say here. It's on, so as soon as I hit play, I should be starting as a client. So here's my name, that's me, and I'll wait. Here we go. So there's a couple of warnings, I ignore that. Click close on the visual menu. So here we have our player. We're nothing but a capsule, we're running around. Here's our fancy door. And I forgot something actually, never mind, I didn't. VRChat does everything for us. So as you can see, we have the interact function on the script. So as soon as I hover with that pointer on the object, we see the interactable thing. I click on it, boom, and there's our door. And I can walk through. I can't close it yet, but you can probably guess how you can do that now. So I showed you how to open it. When I click it again, nothing happens. And yeah, that I think concludes this now a little bit longer tutorial, but I showed you everything that there is to know except one thing. So let me close this one. When you go to project settings, I think it was preferences, general, there is a very cool thing called code coverage. So when you use tests, you sometimes want to know if you actually test everything that you have written. When you do test-driven development, you don't really need this, as every line of code you write should be covered by a test. So let's enable this, and whoops, it complains the package is not installed. Okay, let's install it. And here we go. It does it for us, and I have to restart the editor afterwards to be enabled. Oh my god. Okay. Okay, this is stupid. So I'm gonna go here, like it was packages. And I'm gonna kill file, edit this one. Code coverage, that is delete, save. So this might work at a later date. I had it working in the other project, I'm not gonna bother now. So there's one thing missing. We have our first tests. I haven't shown you yet how to create tests for private code. So go to this, let's make the default layout again. You can see that. So runtime, here's our assembly definition, our door script and the door. So let's say I have in the test, there we go. Or we have in the door a private function. Oh, there we go. So we have in this code, we have a private function, private void hello world, and it just logs hello world like this. Element. So it does really nothing. And I want to Let's say make this nothing. So I want to test this. Private, obviously, you can't access from here. So if I like write a test for that, hello world test, and I have my door. I say door dot hello world. That nothing appears here, right? So it's not here. To fix that, we can go to the directory where the private function code is, and we create a new file. So I call it C# script, and it will be a file called assembly info. I think that was the name. And in that file I delete everything, and there will be a thing called internals visible to, and now I need to put in the assembly definition name. So the assembly definition name is goribo.tests.editor. So it will be goribo.tests.editor. And what does it want? I forgot something. Unity items visible to solutions visible to. There it is. Ah, there it was. I forgot it. So I need this in front of it. There we go. That's that. So here we have now, it's not there yet because as it said, it needs internals. Our code is private, so change this to internal. And now this code can't be seen outside of goribo.runtime except in our assembly goribo.tests.editor. So in here now I have hello world. And if I run this, it should spit out the error. There we go. Error hello world. Unhandled log message output. There we go. There is our error and internal code that is not public and can't be seen outside of the door usually. So I hope this is useful. With that you should be able to test most of the thing. As soon as you test anything with players, let's say instead of this you have player something. So you have a player, you create that by creating a new VRC player API, which doesn't exist here, but it's in VRC SDK base. So I can import that. It will still fail because I have to add this VRC SDK base to the assembly definition file. So in our tests we have editor, the assembly definition, and now I need to reference the assembly itself, and it's called VRC SDK base, that is. And click apply, and now the code should compile as well. And now we have a player, which is not useful yet, because when you test like this, every bit of functionality that the VRC player API or the VRC player API provides has to be filled by yourself. It could in theory be filled by, for example, CynEmu at some point, but it doesn't support it yet. So I usually create whatever I need on the fly and slowly filling it up into a small test utility. So here I have, for example, player.id, player.id, and that is by default null, 0, sorry. Yeah. That is testing. Basically, it should give you a rough idea of what's possible, and there's probably better ways of doing this. I wanted to show like a short example of what is actually possible, and it's actually quite nice to work like this. It is tedious a bit, but the good thing is you break something, you know that you broke it in the last minute. Depending how fast your test cycle is. Like the more you have in your project, obviously it takes longer to compile and retest. But here, this is like pretty fast. This is very satisfying to see, to see green arrows, green ticks appearing when everything compiles. So you can also create play mode tests. I'm not touching these yet because it's a bit of a waste of time currently for me, at least. Most of the functionality I create, I can test in the edit mode, and it's faster. That's it. I hope you enjoyed this one. It might be a bit long. Please forgive me. Yeah, that's it. Bye bye.